Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq Raf'ee and my matrix number is 208336. So in this video, I'll be explaining on the part 2 of lab report number 8, in which the title is RL circuit natural response. So let's look at the calculation and the question given. So first of all, let's refer to the question. The question stated that the switch in the circuit shown has been closed for a long time and it is open at t equals to 0. So this circuit, the switch is closed for a long time, and then at t is equals to 0, the switch will be opened. So currently, initially, when the switch is closed, it is in a steady state. So let's move on to the initial value to finding the initial value of the current. So during the steady state, as we all know that the inductor will act as a short circuit. So this will be the circuit to find the initial current. So to find the initial current, we need to use the Ohm's law, and we need to find the resistance equivalent for the circuit that we will be using, in which that the resistor will be connected parallel to either this one or this one, and then we'll find the resistance equivalent as 5 ohms. And then we need to also find the voltage for this circuit, in which using the voltage division we can get the voltage is 75 volts. So from there, using the values here, we can use Ohm's law and find the initial current, which is negative 12.5 ampere. Is is also the initial current, and IL is the current flowing through the inductor initially when the circuit is in steady state. So let's move on to question B, to calculate the initial energy stored in the inductor. So initial energy stored before the switch is opened is using the initial current. So the formula is initial work equals to 1 over 2 inductance minus to the current initial to the power of 2. So we will be getting that the initial energy stored during a steady state in the inductor is 625 millijoule. Then we need to find the time constant of the circuit for t is more than 0. T is more than 0 is when the switch is opened. So when the switch is opened, we can get this circuit, because when the switch is opened, the current cannot flow through here, because it's not a complete circuit. It's not a closed circuit. Thus, we can get the circuit as this one. So the circuit for this is the inductor will dissipates the energy stored during the steady state to this resistor of 2 ohms. So to find the time constant using this circuit, we can use the inductance and the resistance here and get the time constant 4 milliseconds. And then we can convert it into hertz to use it in the next question that asks for the numerical expression for current on the certain time for time after or equals to 0, which means the value, the expression of current on a certain time after the switch is opened. So the formula is the initial current times with Euler to the power of negative t over time constant. The value will be negative 12.5 Euler to the power of negative 250 t ampere. So the t is the constant that will be changing because it will be using on a certain time after the switch is opened. Lastly, the question asks for the energy dissipate through the R2 to the 2 ohms resistor after 5 milliseconds in which the switch has been opened. So the function, the expression for the work, the energy dissipated is work on a certain time equals to 1 over 2 times with the current initial to the power of 2 times with 1 minus e to the power of negative 2t over time constant tau. So the T will be 5 milliseconds, which means that the energy dissipated after 5 milliseconds will be 573.697 millijoule. So that is the energy dissipated from the inductor by the inductor after 5 milliseconds when the switch has been opened. So uh, it wants the percentage of initial energy stored that has been dissipated. So we need to be finding the percentage will be the energy dissipated at after 5 milliseconds over the initial energy stored in the inductor times with 100. Then we can get the percentage is 91.79%. So this is the current that will be the inductor that the current that will be flowing through the resistor. So that the graph has been made for this function, which is here. So this is how the inductor, the RL circuit's natural response. So this is how the inductor will respond when it wants to reach its steady state after the switch is opened. So this is the graph. To prove that, we can use the simulation on the multisim. This is the oscilloscope. So at first, the switch is closed for a long time. And then during t equals to 0 or at 5 milliseconds or t is more than 0, the switch is opened. So that is the energy dissipated or the current flowing to the 2 ohm resistor. It will be a negative value. And then this is when the switch is closed back, in which it will be storing on the same function given in this one. Yes. So that is how the uh, RL circuit natural response, in which the inductor will dissipate and store the energy uh, from the circuit. So I think that's all that I can explain. Okay, goodbye. Thank you for listening. See you next time.